reading the big red note that was on my agenda?
Nope, I haven't built it. Can you go back
There was on before I put this on there.
Can you go back to it?
Nope, but we're going to talk about it.
No, I didn't.
So one other thing too, some people might want to cut around the dotted lines on this to make it line up nicer. That's fine, but we're not going to use class time to do that. So if you wanted to look nice by cutting on the dotted line here so it lines up better, then do it on your own time because it works just fine for what we need it for, to be folded like this. Okay. On the red note that was on the agenda, it says that I found out yesterday that the Desmos program that we've been using is not the one that you get to use on the STAR test. It is locked out of being able to graph standard form. It's locked out of being able to graph inequalities, just like the calculator is. You can only graph it when it's in y equals mx plus b form, which means you have to practice rearranging problems to be able to use Desmos or the graphing calculator. Huh?
Did you just erase that marker off that paper?
Yes, because I have it in a protective sleeve.
Can I just stay for this and give to you the works on the back and the work problems?
So that being said, I'm extending our tests to not be until on Wednesday and Thursday next week instead of on Monday and Tuesday. We're going to take extra time on today's lesson because it's got good practice of rearranging stuff so that we are able to use Desmos and the graphing calculator still if needed, but you'll know how to rearrange them because it will take a little bit longer than it would have if Desmos was able to just graph it easily for you. Okay, so remember when we did linear inequalities and we had to determine whether it was a dashed line, boys, whether it was a dashed line or whether it was a solid line, and then we had to shade. So this is a reminder right here of when you're graphing inequalities, what the symbols mean. So the two symbols without the line underneath, okay, are dashed lines, okay? So both of those are dashed lines. The ones with the line underneath, so these two, the ones with the or equal to the line underneath, those are solid lines. Okay, boys. And then the two less than symbols, the ones where the small end comes first, as you're reading the problem, the small end comes first, you're going to shade under the line or below the line. Okay? So you're shading down the y-axis. For the ones that are greater than, that means they have the big end first as you're reading the equation. The big side first is greater than, okay? And you're going to shade above those because it's greater than. Okay? So this is just a refresher because as you're graphing today, when we did systems of equations, we had two lines, right? And wherever they crossed, that was the solution. There was only one solution, and it was wherever they crossed, right? Okay. So for linear inequalities, however, we have shading, okay? And wherever both are shaded at is your solution. And so that's why you needed two different colored pencils, because we're going to be shading and graphing two different inequalities. So right here, so the very first step, and this is an important one because our graphing calculators that we're using, that we're allowed to use, will only graph them if they're in y equals mx plus b. Yes? Okay. Y equals mx plus b is the format that you need to have it. What does the stand for?
Slope. Y, oh wait, and then
The
the X
slope.
is the Y intercept.
Yeah.
What is that?
Different marker, right? Slope. Okay, and the b is what?
Y intercept.
The y-intercept.
Yes, sir.
Okay. So if you do not have that memorized, you may need to write you a note at the top. If you know that, you don't have to write the note at the top. Okay. However, if you're still forgetting this, the more times you write it and say it, the more you're going to remember it. Okay.
Y equals
Our
MX
slope,
plus B.
when we're graphing it, is rise over run.
I remember Robin Run.
Okay, so now look at this very first example here. Okay, this first example, are both of these already in the y equals mx plus b form?
No.
Yes. Yeah.
They are. We just have
yeah.
inequality
Yeah.
symbols, right? But yes, y is listed first in both of them. And that's the only thing on that side of the equation. So how am I going to start graphing this first one right here?
Okay,
Where do I start?
Go down. Well, at -5.
Okay, go down to -5. Up to over 1. It's a whole number, so we have to make it a fraction by putting a 1 underneath. Because 2 divided by 1 is still 2, right? So up 2 over 1, up 2 over 1, all the way across your graph.
Okay, where are you working on that? Is it the bottom one? Okay, I see it. Yours was white, so I didn't know if you were on the packet.
It's actually green. It just projects up there white. So is this going to be a solid line or a dashed line?
Yeah.
Solid.
Solid.
A solid line.
It's gonna be solid like a whole body.
Okay. Solid line.
Whole body.
Is this when we use different color spaces? And it's
To graph the different lines, yes.
it's gonna be.
Okay. So LaParis is saying because my symbol is greater than, I'm going to shade up the y-axis. Everybody agree with that?
Oh, yeah, why not?
Yes. That is correct. She is right. Okay. So now for my second line, where do I start when I'm graphing it?
+2.
Okay, up to.
And then you can go down.
Have mercy on me, have mercy
Okay.
on me.
A negative is -1, so it's -1 over 1. So down 1 over 1, down 1 over 1. So it's going to be a 1 like this.
Down one.
Is this going to be a dotted line or a dashed line or a solid line?
Dash.
It is going to be a dashed line.
Thirsty.
Okay. If you are using something that doesn't erase, okay, and you accidentally draw a solid line, the way you can correct that is by drawing little hash marks like this through your line to let me know that you know it's supposed to be broken up. Okay, so that's the alternative to the dashed only if you can't erase sections of your line. Okay. So which way am I going to shade for this one?
The top.
The top we're going to do up the y-axis because that's the top. Okay. Okay. So now, where are they overlapping at? That's the only area that I really care about. Where are they overlapping at?
2.5.
2 negative, or I mean 2 0.
This top part, right? They're overlapping at this top part. It's the shaded area that we're talking about, not the actual lines. We're looking for the shaded area. Okay, so this is the solution area. Okay, all of the points in this area and on to infinity going up that way are possible solutions. So that being said, right underneath that, we need to come up with 3 possible solutions that fall in that shaded area. Would 0, 0 work?
No.
No. Okay.
What is it called? 2, 0.
2, 0, right here. It actually would work because it is not where the lines intersect. If these 2 lines intersected at that point, actually it won't work because it's on the dotted line. That's what I was going to say. It's on the dotted line, so that actually does not work either.
2.
But we can do 2, 1, right? So 2, 1 would work. What about 4, 3? What about over here on this solid line?
Yeah.
That would work because it's on the solid line. Okay, so 4, 3 does work. But what about -1, 3? Would -1, 3 work?
Yeah.
What about 3, 2?
Okay, look, -1, 3 is on the dashed line, and anything that falls on the dashed line does not work.
That's not gonna work.
Oh my God, but then don't say it's gonna work.
So, but -1, 4 would work. Okay, so -1, 4. What about 1, 500?
No.
Yeah.
Yes, it would fall way up here, up this 1, right? It would be in the solution set. Right? Just because it's not on the actual graph doesn't mean it's not a solution set. Or a solution point. So look at this next example.
Bro, who did that? You go for a ruler? What?
Come on, guys. Next example. Is this one in? Is the first one?
The first one is, but the second one.
Okay. The first one is where I can graph it. So where do I start? Up 5. Okay.
Yeah, 5.
And then you wanna go,
Down 1 over 2.
Down 1 over 2. Yeah.
Down 1 over 2.
1 over 2.
Whoa.
Is this going to be a solid line or a dashed line?
it's gonna be dash. No, it's
It's gonna be a
all
solid.
Stupid. That's very stupid.
Which way am I going to shade?
the bottom half.
The bottom, down, because it's a less than.
Let's get it done.
Break
Right.
all.
Get it done.
Okay, so now this next one, is it in the format that I need it in?
No,
Now,
No.
not.
So what do I need to do for it?
We need to fix it.
Okay, how do I do that? What's my first step?
fine, you got this.
That, do the,
I don't know.
that age over.
Right, you can use the CHIMP method, so you can use -a over b to get the slope. Okay, and then what's the y-intercept? How do you get the y-intercept if you're using the CHIMP method? B over C, yep, the whatever's in front of. So this is gonna give me my y-intercept, and that's gonna give me my slope. So I can write y, and then I can do -2 over b, which is -1. So -2 over -1 is actually what?
Negative. Or positive.
Positive 2. So that would reduce to a positive 2x. Okay, and then b, which is -1 over, or sorry, I did that wrong. It's c over b. Sorry, c over b. I knew that was right.
So 4 over 1
Okay, so 4 over -1,
will be -4.
-4. Okay. But how do I know what symbol goes right here?
Because.
It would be that. Oh,
It would
We
be
might have
y
to-
equals mx.
We might have to flip it, right? Because
Because it's negative.
if there's a negative in front of the y, if you use this method, it is perfectly fine to use this method. It's a shortcut method. But in inequalities, you have to also note that if the y has a negative in front of it, you have to flip the sign for your final answer. Okay, so if your y has a negative in front of it, you have to flip your sign for your final answer. Okay, now I'm going to work this out, showing the steps to work it out instead of the shortcut. Okay, so I'm going to erase this final answer right here for just a second. Okay, and if you don't remember, boys, if you don't remember the shortcut, then you can always work by just rearranging it, right? So
Yeah.
subtract the 2x from both sides, and we've got negative y is less than negative 2x plus 4. Okay. And then we've got a negative 1 in front of the y, so we've got to divide by a negative 1 for everything. And this is where, because I'm dividing by a negative, that this sign has to be flipped. So at this point, I circle it so that I'll remember to rewrite it the other way when I am writing my answer. So now I can graph it down at negative 4 up 2 over 1. Okay. Is this going to be dashed or solid?
Dash.
Dashed.
Yeah, it'd be that. Okay.
And which way am I going to shade it?
Shaded the,
Up or down?
Up.
The y-axis. Up
No,
the
down,
y-axis. Nope, you're right. Up the y-axis because I got to look at this one and its y is greater than the one I rearranged. So it shades up. So where's the area that they overlap at?
Gonna be that's
All of this little side area right here, right?
Now I'm going to rock, Alan. Yeah.
So now this one, it doesn't give us the problems, it gives us the graph, and we're supposed to write the inequalities.
Alright.
So we're gonna write them in y equals mx plus b. So I know I already need a y and an x. Am I gonna do my solid one or my dashed one first? The solid? Okay. So where's my y-intercept for my solid line?
4.
At 4. So positive 4. What's my slope? So down 2, backwards 1. So negative 2 over negative 1, which reduces to what?
Just positive.
Positive 2. Okay. And then,
Why do you keep erasing it? I can't see what you're writing.
well,
Well,
we're right
it's
here,
up, right?
negative 2
So
over
it'd be
negative
greater.
1, and we were reducing.
Bruh, some of us are slow.
Well, if you would not be making farty noises
That was a
and
real
also be paying attention to the front instead of each other.
I'm just confused.
So I was counting my slope, down 2, backwards 1. So then I just rewrote negative 2 over negative 1, simplified for my slope.
Okay. So it would be greater than that.
It's greater than, because I'm graphing up. If you're not sure, then just extend it. And you can see it's graphing up the y-axis here, so it must be greater than. Is it going to have the or equal to?
Yes.
Yes, because it's a solid line. Okay. Okay, so then my dashed line, okay, what's its y-intercept?
So intercept is 4.
It's also at positive 4. Okay, and what's my slope for it?
So is 1 over 1.
Down 2.
Well, wouldn't it be the
Down
same?
2.
Over 1.
Oh, I
Down
was
to
looking at the other line. Hold on.
Down to over 3.
plus
over 3. So -2 over 3 for the slope there.
It's
And so-
dotted, it's a dotted line, so.
It's a dotted line. And if I needed to shade more to see where it was shaded on the y-axis, it would be shaded like this. So would it have been down or would it have been up?
down.
It would have been down the y-axis from the y-intercept,
The way you
right?
just stated it was down.
Yes, it is down. So that makes this a less than, right?
Yep.
So that's the end of our notes, but we're going to do an example on the assignment together really quick. Let us do this example first. Okay, so this very first one right here, okay, this space right here is for your answer, not necessarily for your work. You can use it for your work, but if you need to, then put you a box for you to still have room to put your answer in or something. But you're more than welcome to do your work on a whiteboard when you're just rearranging. Okay, so this first one, we're going to have to rearrange, right? So I'm going to do my work right here just because I want y'all to be able to see it. How am I going to solve for my y? Minus my x, come on guys, minus my 9x.
Okay, yeah, so cancel it out. And it's just like that.
Then it's,
Okay, this one has an x and this one doesn't.
X, right?
So can I combine them?
Negative,
No.
no, it's negative, or it's
It's
6.
-9.
-9 plus
Oh.
6.
Yeah.
You can put the minus 9x afterwards, but then you might get confused for the y equals mx plus b because we're used to seeing the x first, right? Okay, then what's next?
And divide by 3.
Divide everything by 3. Do I have to flip my sign this time? No, because it's not a negative. So it's y is less than or equal to negative 9x divided by 3 is
3.
X.
negative 3x, and 6 divided by 3 is
2.
okay. So I'm going to rewrite this right here above so I know which one I rewrote this for. Negative 3x plus 2. Because that's the one I'm going to look at for graphing. Do I need to rearrange the second one?
No.
No. So I'm going to circle it so I know I didn't need to rearrange it. That's the one I'm using to graph. So you have blank graphs on the back of your paper there so you can graph them.
I'm on the wrong problem.
Huh?
I did this on the wrong problem.
Alright, so to graph this very first one, we're going to go up 2, right? And then what's my slope?
Negative 3. What?
So just down 3?
So are we matching or graph?
Over 3.
Down 3 and then
Where-
over
Where is that?
1, down 3 over 1. Okay, you have a different looking graph on the back, but I needed all the work to be able to be shown up here.
So wait, it's, what's the slope again?
Down 3 over 1, that's negative 3x. So the slope was down 3 over 1.
Wait, how is it over 1 when it's 2?
It's not, it's a negative 3x.
Plus 2.
This plus 2 is your y-intercept.
Oh,
Makes sense. Is it a dotted or a?
You tell me.
Oh, you're talking about the,
It's dotted.
It's dotted, yeah.
what's it called?
No, it's not dotted because
solid.
it's an inequality.
Got a line from it.
It's got a line underneath that, but it's solid. Okay, which way am I going to shade?
Look.
So down
What
the y-axis, that's what I'm talking about. So down the y-axis, yes.
Ms. Stewart, I have a question. What determines which way you shade?
The symbol, if it's greater than, so I always look at the y-axis. So if it's greater than, I look at my y-intercept and I'm going to go, well, my greater than y's is going up. So I'm going to shade this side that has my y's that are getting bigger. If it's less than, then I'm gonna go to my y-intercept and I'm gonna say, well, I need to go down because I need my y's to be less than or smaller.
And up, you change to the up.
Yes.
So where's the next line at?
Okay, so then this next one, what's my y-intercept for this one?
Y greater than X, less,
What's my y-intercept?
3X. My negative.
Hey, your y's too.
Oh,
I'm looking at this one right here.
Oh, that's.
We already graphed that one. I'm looking at this one right here that I circled.
oh, it's X,
What's my y-intercept?
X. One.
Nope. What am I adding out here?
Oh, plus 2.
No.
Zero.
I'm adding nothing, right? And nothing is 0, so it's gonna go through the origin.
Oh.
Okay.
Oh, you're
So
so
anytime
smart.
you just see the letters X and Y with whatever symbol in it, it's that parent function, and it's, what's the slope?
0.
Nope, 1, which is up 1, over 1. So anytime you see, like I said, just an X and a Y, then it's this line that goes straight through.
That one's gonna be done.
If 1 was negative, it would go the other direction. Okay, this one's gonna be dashed or dotted, yep. Okay.
And it's gonna be shaded, down.
It's greater than, so the big side is towards my Y, so it's gonna be shaded up. So where do they overlap at? Right, in this area right here. Okay, so now my graph, I'm gonna take and I'm gonna look at all my graph choices on the back here. Which one matches my graph? Has a dotted line going up through 0, a solid line going down through 2.
Wait, so which side do we shade? Oh, never mind. I got it.
I think it's O or,
Oh.
O or
No, I think
G.
it's, I think it's two.
So, okay, so let's look. O is shaded up here in this top part,
Oh, it's G.
It's G.
okay, and G is shaded over here. And A is the other one that's kind of similar, but it's shaded on the wrong side, right? All together. So it is G.
So we put G in the
So
bottom.
back in here where that your answer space is actually at, okay, you're gonna put the letter G, and you need to list one possible solution. So what coordinate, any coordinate that's in this solution set?
0, 0.
0, 0 is not actually because it's on that dotted line, so it doesn't work.
One.
No, negative.
Oh, no,
Negative
1, 1, 1. Up to 0.
So negative,
0, 2. 0, 2.
negative 1, 1, 0, 2. Okay, 0, 2 would work because it's on a solid line,
Yeah,
yes.
exactly.
Okay, any point that's in this shaded part or that falls on that solid line in the shaded part is a solution. Okay, so you only needed 1. Now, you may work together in small groups as long as you are working. And yes, whoever has to go to the restroom can go to the restroom really quick.
You go to the rest of the room.
No, I'm fine.